Hello, and welcome to your first virtual lesson in Algebra 2. I'm Mr. Lambright. Mr. Austin and I are going to be trading off on these videos, going back and forth as the semester goes along. Before you get started, you're going to want to find a blank copy of these notes in modules on Canvas. That's if you're following along at home. If we are currently in school in person, I'll be giving you a paper copy of these notes. If things move along in this video too quickly, please pause, go back, rewatch, whatever you need to do. But we are going to try to move along at a fast pace because in this lesson, we've got a lot of review to cover. So, with that being said, let's move on. The notes that we're going through today cover two different lessons, one about the properties of real numbers, the other one about evaluating and simplifying algebraic expressions. So there are a few things we need to know up front when we talk about certain types of numbers. We've got real numbers, which is, they're made up of a group called rational and irrational numbers. The rational numbers are the ones that we normally think of, that we can really get our heads around. Usually that would be fractions that either end, like 3/4 becomes 0.75. And we could also do repeating decimals that we can write as fractions. So even though 0.3 repeating goes on forever, 1/3 is considered a rational number because it's the same thing. Irrational numbers are the numbers that can't be written as a fraction or decimals, like the square root of numbers that don't have a perfect square, like radical 2 or pi. And we're going to be introducing you to other numbers like that as the semester moves on. There are also a few properties for algebra to work that we need to know about right up front. The commutative property is the property that says the order you do things in doesn't matter. So for addition, that means a plus b equals the same thing as b plus a. We're going to do basically the same thing for multiplication. The order that you multiply things in doesn't matter. A times b equals b times a. If you do 2 times 3, it's the same thing as 3 times 2. If you do 2 plus 3, it's the same thing as 3 plus 2. That's what the commutative property is. The associative property is about how the way you group things in parentheses doesn't have an effect as long as it's all the same operation for addition and multiplication. So if I were to group between A, B, and C, B plus C first, it wouldn't change the answer if I grouped A plus B first and then added C. The same thing goes for multiplication. I can do A times B times C, and it would equal the same thing as A times B in parentheses times C. So 3 things added together, it doesn't matter the order that you add the first 2 or the last 2, you're going to get the same thing. 3 things multiplied together, the order doesn't matter either. The identity property is the thing you can do to a value and not change it. So for addition, the only number we can add that won't change anything is 0. Anything plus 0 is itself. For multiplication, the thing we can multiply by that won't change anything is 1. A times 1 equals A. And then finally, we have the inverse property. This is the idea that there is a thing you can add to any number that will undo it. So if we have A, the only thing we can add to it is negative A to undo it and get 0. For multiplication, the thing that we can multiply by is the inverse, which is 1 over A. And that is how we get 1. If you need a second to get the properties down, please pause now. The distributive property is separate from both of these because it actually uses both multiplication and addition. The idea here is we have A times B plus C, and to do that we need to multiply both things inside the parentheses by A. So we would write A times B plus A times C. We're actually going to do that with some numbers here in a second. So if I look at these problems that just popped up, I've got this -3 outside the parentheses. I'm going to multiply both of these items inside the parentheses. -3 times x is -3x. -3 times -4. That's right. The negatives are going to get multiplied together, and that makes a positive number. 3 times 4 is 12. Then we've got this 5 that needs to be multiplied times the whole of 2x. 5 times 2 is 10, and then we have the x. And then 5 times -7 is -35. The most common mistake people make with this is not paying attention to their signs. And in fact, that's one of the most common mistakes people make in all of algebra. Let's move on to unit analysis and conversion. We've got this job. We work 4 hours. We earn $36. The question is asking, what is your earning rate? Now, a rate is really the easiest way to think about it is we've got blank per blank. And that per is like a division sign. It's like the fraction bar. In this case, we know we're making $36 per 4 hours. And the best way for a rate to make any sense to us is if we can reduce that rate into something with a denominator of 1. And fortunately, we know that 36 is divisible by 4. We get 9, and that would mean we have $9 per 1 hour, which we would say $9 per hour. Writing it as a fraction is actually really important for the next couple of problems. And while that's something you would also do in chemistry, we want to make sure that you understand how to do it when it comes up later in Algebra 2 problems. Here's another rate problem just like the last one. We've got something per something, and in this case, we know we've been going 50 miles per hour. And we also know that we're trying to find how far we went. And the cool thing is that units actually cancel out in a fraction the way numbers would. So we know we traveled for 2.5 hours. So this is a case where we would multiply by 2.5 hours. 50 times 2.5 is... Yep, it's 125. So we're going to have 125, and then we have to figure out our units. Like I was saying, units actually cancel. So when we have on the top of a fraction hours, and on the bottom of a fraction we have hours, and this makes sense because we wanted to know how far we were going to go. The answer is going to be in just miles. This one's probably going to be our longest problem of the lesson. We're trying to convert entire units here. So we've got 45 miles per hour. And we're trying to get this whole thing in feet per second. So both miles and hour, they're going to be gone by the end of this. You learned a long time ago that there are 5,280 feet in a mile, and we're going to actually use this information that we have about the way units cancel to figure out how to multiply. So we know that there are 5,280 feet in 1 mile, and that 1 mile has to be on the bottom to cancel with the mile on top. And that means we're going to be multiplying by 5,280 feet on top. Now, I'm kind of smushing this in here because I have a couple of other conversion factors to go because I don't know how many seconds are in an hour, but I do know how many minutes are in an hour. I know that 1 hour contains 60 minutes. The hour has to be on top to cancel with the hour on the bottom. and then we're going to have 60 minutes. And then I also know how many seconds are in a minute. So I'm going to have 1 minute, and that is going to equal 60 seconds. So now we've got this math that's going to be a pain, but thankfully we are totally allowed to use calculators in this class. So my miles are going to cancel. My hours are going to cancel. My minutes are going to cancel. And we know we're going to have feet on top, seconds on bottom, which is exactly what we want. The question is what our answer is after we do the math. So in your calculator, you're going to do 45 times 5,280 divided by, and because both 60s are on the bottom, you're going to need parentheses to keep this together, divided by 60 times 60, and then close the parentheses. And it turns out our calculator is going to tell us that that is going to be 66 feet per second, which we would normally write with the feet and the second as their own fraction. So more like 66 feet per second. These are going to be slightly simpler conversions. We start with 150 yards, and we want it to be feet. We happen to know from the past that there are 3 feet in 1 yard. So we're going to multiply by 3 feet and 1 yard, knowing that the conversion had to work that way so that the yards would be canceling each other out. That's how we knew we had to multiply by 3. The 3 had to be on top. 150 times 3 is 450, and it's now in feet. For the next one, we're converting gallons to pints. We got 4 gallons. I bet you don't remember how many pints are in a gallon. I happen to know that there are 8 pints in 1 gallon. We're going to multiply just like that because the pints will be on top, because the 1 gallon has to cancel with the gallon on top with the 4. Gallons are canceled out. 4 times 8 is 32, and it's now in pints. We also want to make sure that you remember how to do the order of operations. You probably learned this in the past as PEMDAS. The problem with PEMDAS is that it makes you think that all the multiplication has to come before the division and all of the addition has to come before the subtraction. So you see, we've got the same letters in these notes, but we have to make sure we understand that multiplication and division happen from left to right. Addition and subtraction happen from left to right. So we do our parentheses first, then we take care of our exponents, then we multiply and divide, then we add and subtract. And we're actually going to do that from the inside out in case there are multiple sets of parentheses. I've thrown a couple of examples up here. If you want to pause for just a second, you can get those written down before we actually start doing the problem. So let's look at number 1. We've got parentheses. We need to do what's in the parentheses first. And in that case, that means taking -3 minus 1. It gets more negative. We're going to have -4. So we got -3 times 2 times 2 times -4. And those are those multiplication dots in case they look a little funky. What you're going to notice, and someone is going to tell me that I'm doing it wrong, but that -4 is no longer an operation in parentheses. It is just multiplication. It's that 2 times the -4. This is all multiplication now. And we can do it from left to right, but we learned earlier that we've got a property that tells us we don't have to. The order that we multiply in doesn't matter when it's all multiplication. I'm still going to do it left to right because I don't want you to get mixed up. But we know -3 times 2 is -6. Negative 6 times 2 is negative 12. And that is going to make the answer to this problem 48 when we do negative 12 times negative 4. We also have this second example, and it's actually got an exponent in it. What you're going to see here is we've got this guy that's in the parentheses with the number. So when you're typing that in your calculator, you're going to want to type the parentheses. That means negative 4 squared is negative 4 times itself, which is going to get rid of the negative. But then we've got this guy right here that's going to make it negative again. So nothing's going to happen here for a second. We know we have to do the parentheses first. 1 minus 5 is negative 4 again. And then we've got this this exponent, and I'm going to write it in the same step because I already took care of my parentheses. So we got minus, and then negative 4 times negative 4 is positive 16. I already took care of the parentheses. I'm done with them. I left them here because I've got a little bit of an issue. We know negative negative has to change, and it becomes positive. We got a positive 4 there, minus 16. These two are going to cancel out to 0, which is going to leave us with just an answer of negative 16. We're going to hit you with some vocabulary real quick before we move on. When we have these guys, these numbers in front of letters, the numbers are called coefficients. Coefficients. When we talk about coefficients from now on, we are talking about the numbers in front of variables. And by saying the word variables, I've spoiled the next one. When we've got these letters, they are called variables. You've also heard them referred to as unknowns, but in Algebra 2, we pretty much just call them variables. Now, what does that mean for this guy right here? Just a number. The number, if we think about variable as something that changes, it varies. Something that doesn't change is constant. That's the definition of the word constant. It does not change. And a constant is a number that doesn't have a variable. We've also got two parts of exponents to talk about. Each exponent has a big number. We call that number the base. And then we've got the little number. And that little guy is the exponent itself. This has an answer, but we're really more concerned about the base and the exponent than figuring out what 7 to the third power is right here. We are going to wrap up this video with combining like terms. The idea behind like terms is that we have the same letter, the same variable, and the same amount of that letter with the exponent. So when I look at a problem like A, these guys have x's, and this one does not. So I'm going to want to only combine the two that actually have x. So 8x plus 3x is 11x, and I do need to use the signs that are on the variables, or on the coefficients, and then plus 5 stays the same. It doesn't combine with anything. Now that's important because in the next problem, we don't have any constants. Everything's got a p, but they have different amounts. So we've got these two that have p squared, and then we've got p. So 5p squared minus 2p squared, and then the minus is very important here. That's going to be 3p squared. That minus is stuck to that 2. And then the 1p is going to stay 1p. We normally don't write a coefficient of 1. And for problem C, the big takeaway here is that we can't combine things that have different letters. So I've got the x's, I've got the y's. I'm going to put my marks there. and here. And the other thing that we've got going on here is this time the y that doesn't have a number, that's going to be important. We know we've got an invisible number hanging out in front of y, and in this case it is an invisible 1. The invisible number is almost always 1. Just please don't forget that. When we've got these two terms that have x, we got 2x minus 9x. The minus belongs to the 9. 2 minus 9 is negative 7 with the x. And then we got negative 3y plus 1y. Negative 3 plus 1 is negative 2. Nothing else is going to combine, and that problem is done. Looks like I accidentally skipped a slide earlier, so we are going to talk really quickly about simple substitution. When I've got a problem that says, evaluate this that has x's in it, but do it when x is a different number, we're just going to plug that number in. So everywhere we see x, we are going to put negative 3 in, but in parentheses. So I've got 4 parentheses negative 3, close parentheses, squared. Then I've got minus 6. Instead of x, I'm going to put negative 3 again, plus 11. This is called substitution. It's different than the substitution that you learned with the graphs. We're going to get to that here in a little bit, not in this video. But it is substitution. So now we've got to do an order of operations problem. Let's start with the exponent. We know negative 3 times negative 3 is what we're doing with this squared. So instead of 4 times negative 3 squared, we're going to have 4 times 9. And that's the only thing we do in the exponent step. Now we've got multiplication to take care of. We've got 4 times 9, which is 36. We've got negative 6 times negative 3, which is positive 18. And we've got 11. And then the last thing we have to do is to add those three numbers together, and we get 65. I know we just reviewed a lot, but if you have questions, you can either go back and rewatch the parts that you're still confused on, and if that's not going to help, please message your math teacher, whether it's me or Mr. Austin or someone else in the math department, if you have any questions. We definitely want to make sure, especially if you're learning from home right now, that you are able to understand what's going on. We will see you back here with the next video in our next lesson.